Good day, everyone. Welcome to the part 11 of the Dart series, Learning Dart from Scratch for Beginners. And in this video, we'll be talking about assignment operators. Yes, I think I may mention it in, I think, part 8 or so, that we're going to be diving more deeper on assignment operator. And this will be very simple and short, something very simple actually. But let's get right into it. We have what we call assignment operators, and that's definitely we are learning that. We can clear our terminal and we can use our void main. Actually, I've explained this also in some of our previous video, that is a functional and object-oriented programming actually. All right, what we'll be learning here is assignment operators in that, and definitely we can have a yes. What assignment means: first assignment operator is this guy equals to, and definitely this guy is going to be having some, it will be and with other operator, and it is still assignment operator. Okay, just let's see what I'm trying to say. We print, we have a 10, then we have a plus equals to, we print it. You can see that now we're adding 5 instead of having a separate variable. You can see that's why the AI actually put that comment there. Instead of having a separate variable or the same variable and plusing it, something like this, you can see we can have something like this actually. Copy it out. I want to copy it out so that I can see clearly what is actually there. And you can see instead of having a equals to a plus 5, we can try to manage our memory, because all these things that we are declaring, don't worry, later on you will learn code optimization in the future, probably from me or from somewhere else. You get to understand code optimization, that most of us engineer, we want to write smaller code that can do bigger things. Yes, and the more smaller your code is, the lesser the heavy, the weight, the size of your application, and the faster and optimize the application is going to be. Instead of having a, because each of the variable has memory that they actually been assigned to them, and the more variables, the more unnecessary computation, the more heavy the application and is going to be, and the operation is going to be. All right, instead of having a equals to a plus b, we can, so far we are just adding 5. Instead of having a equals to a plus 5, so far we are just adding 5 to a. Why don't we just say a plus equals to 5? It's still going to do the same thing as a equals to a plus 5. Or instead of writing b, instead of writing b, int b, instead of writing int b, because we never declared the variable before, instead of having int b equals to a plus 5, so far this b is doing nothing. Definitely we don't need it. We can just say a plus equals to 5. It will still do the same thing. All right, and we can just comment all this out for now. And yeah, you can see, let's run. Oh, sorry, I'm still running logical. I can say that run bin, that is assignment operators that, but there's a correction needed on this spelling. Can rename operators, is not correct. Operators, fantastic. All right, then we can run this, and you can see that we now have 15. 10 is the first data stored inside a, then we now pick that a with plus 5 to it, and we store it inside b. Now it is 15. If we didn't use this method, if we turn it to a equals to a plus 5, if you run it again, definitely it should give us 15. Now, not to waste much of our memory and make our app heavy unnecessarily, we can actually utilize this guy. A plus equals to 5. That is where we are going. That is what we actually want to learn. Assignment operators. And you can see if we still run this, it will still give you the same thing. You can see 5 is being plus to A. Alright, then we have the next one, minus equals to. It's another assignment operator whereby we minus 3 from whatever we have. We already have 15 here. 3 minus 15, that is 12 actually. I think I can do that from my head. Alright, I'm correct. Alright, we now have 12. If we comment this one now, we have A asterisk, which is multiplication equals to 2. It's still an assignment operator, and that is 12 times 2. I think that is should be 24 actually. Okay, and let's quickly run that also. And you can see we have 24. And next we have this guy also, the decimal division, and something is wrong. Okay, it's saying that we should put this into double because decimal division is actually going to be inside a double. That means it will not work for this particular. Let's make it an integer division, because we don't want to change the data type. Actually, we don't want to change the data type. Now we make it an integer division, because this is now whatever is now, this is integer, now it's turning into a double, and we don't want that. Okay, let's divide this and let's see. It gave us 6. Actually, there's remainder because it's an integer remainder. Is going to erase whatever is after the remainder. And let's do modulo also. Definitely we can do modulo divided by 3, and modulo 6 divided by 3. Definitely I think we should have 2 also. Okay, the remainder, sorry, is 0. Alright, this is what we called the assignment operator. I think we still have more thing to learn here. Alright, let's look at the increments. The increment. There's something we called increments. Let's create another file for that. So let us increments operators. Alright, we can have void also. We can have main. Definitely. What's this? Come on. This AI stuff is just choking. We have increment operators in that actually. Okay, operators, increment operators in that. Don't worry, I'm going to make use of it. AI is already suggesting so many things for me here. All right, we have increment in operator, and definitely what we've been doing here, part of things we've been doing here is an increment. Actually, the plus is an increment, the multiplication is an increment, I think those are the increment. But most of the time when you're talking about increment, we used to refer it to as plus increment. You can increment by 5, you can increment by 10, you can decrease by 1, depends on whatever you want to do. But there are some operator that specifically is meant for increment just by 1, and that's why we call it increment. Yes, specifically. This is going to be useful when we are doing iteration, when we are looping, when we are doing something like for loop or while loop, whereby we are going to be incrementally incrementing our constants so that our loop can end. Because when we don't have increments, the loop is going to be endless and our app will continue to be crashing. Yes, but just know that we have increments so that when we get there, you'll be able to sync everything together and get to flow on with it. Okay, let's clear this. All right, we have 10 stored in A actually, and we can call it counter or K instead of A, because most of the time it will be K. IJK, we used to use K most of the time. Counter, those are the 3 alphabets we use And most of the time, the nested loop, we have something we call nested loop also. Nested loop most of the time don't use to pass three level, because once it's getting more than 3, then the app is too complicated. Then we find another way around it. Instead of having more than 3 level of looping, we have for loop inside another for loop inside another for loop. It's going to be crazy actually, but let's leave it that way. That's why we have IJK. That's why we have that 3 letter to be used. Although you can use any letter, but it's just a good practice when we use IJK. I means incremental. J is something incremental also, but K is the constant. All right. Okay, we have K, and we assign 10 into it. You already understand that we have 10 stored inside K, and we print. That is 10. And we now increment it by 1, and we decrement it by 1. Let's see what it gives us. And we can just say increment operators. Let's run that. You can see this is what we called post increment. You can see that you didn't see anything. We actually print, but nothing shows up. Yes, this is what we called post increment. This is what we called post increment. Post increment means increase it afterward, like increase it later, not increase it before. And this is what we'll be using in looping, in future looping, like when you are doing something going incremental. I don't know, I just hope you are able to understand this, but if not, just put it in the comment that you didn't understand so that I can make another video to explain it better. When you're talking about incremental in, yes, let me put it this way. When you're talking about incremental in ascending order, yes, when it is increasing in ascending order, we use plus. That is the post increment. The plus is going to be in the front. And when you are doing post decremental, we use minus, and it's going to be something like ascending also. But when you are using pre-incremental, let's see pre-incremental. Let's comment this out actually, so that it will not disturb us. Let's do pre-incremental, and we have, you can see now that the plus is now behind the K, which means +1 with it before you print. This one means print it before you +1. The first one we did is print it. You can see, print it before you +1. That's just what it means, and definitely is going to print. What's going on? It's going to print nothing for us here, but here now it's going to print this first. Okay, let's run and see. You can see now this is 10, and we said add 1 to it before you print, and now it's printing 11 for us. The other one should print, it should just be 10. Why is it not printing? Let me close this guy. But do you understand now? Let me uncomment this guy and print all together. It should print. Cool. Now this is post incremental. Let me comment this back, and okay, we have 10 and we are doing post incremental. Add 1 to it before you print. Definitely is going to add 1 to it and print it out. And you said -1 from it and print, and it's going to -1 from it and print. Let's run. You can see we have 10, it's +1, that is 11, it's -1, that is 10 back. Then the pre-increment, You can see the pre-increment also did the same thing. 10 plus 1, it added 1 to it before it actually prints the 11 out. Then let's do pre-decrement. Can you print this for me? Definitely, I think everything works the same way here, but the experience is actually different when you are testing it with loop, because before the action takes place, it's going to +1. That is the pre-increment. And for the post increment, after the action take place, that is when it's going to +1. That's just the simple logic behind this, actually. All right, I think that will be all about the incremental. Then we have something called ternary. Yes, let's add ternary operation here. And ternary operation is just the comparison. Yeah, the comparison operation, and it's being conditional. This is just a short form of writing if statement. Actually, this should come when we are doing the if statement. Definitely, probably we can elaborate more on that when we are doing if statement, but definitely we can just quickly brush through it here before we move to if statement. We can just have the ternary operators that. All right, this is the ternary operator file. I can have the void main, and we have this. I don't know why AI just keep disturbing my life this way. And we have ternary operator. All right, this is ternary operator. It's just checking if it is it or not. No. I don't know. Let me just brush through. I'm not too sure you're going to get this clearly if we didn't treat if statement itself. This is comparison. Actually, you're trying to compare, but comparing, instead of doing the if statement, then you're using the short form. That is what ternary just means. You're using the short form, checking if it is it. This is what it means in a simple word. We are trying to check the marks. Yes, and we have A 10, which is here. We have B 20. Is A greater than B? It is no. That's false. That is what this means. It's checking if A is greater than B. If A is greater than B, print A, print 10. If A is not greater than B, that is else. This is if A is greater than B, print A, else print B. Are you getting it? If A is greater than B, this conditional is going to be returned. It's storing this A inside max. And if it is not, it is storing this B inside max. Let's print that and see. Definitely from the look of the matter, this should print B because A is not greater than B. All right, let's run this and see. We have that's run ternary operators dot. All right, it's saying it's not saying ternary operator. Let me see. Ternary operators. What's going on? All right, sorry, we didn't put bin. That is why. Bin slash. All right, you can see that it's print 20, which I told you is going to print 20 because A is not greater than B. If it's A is greater than B now, it's going to print A, which is 10. But B is greater than A, definitely it's going to print B. All right, let's check the second example that AI gave us. It's doing modular. That's one of the importance of modular. We can use to check if it is even. Even number are just number that is being divided by 2 and itself. Actually, 1 is not part of it, though 1 it can be divided by 1, but the way we are able to know that it is even number, it is 2 is going to be divided by 2 without remainder. That is even number, and that's what we are doing. You know that when you divide modulo, if you do modulo, which is using the percentage symbol, when you do modulo, it's going to return us what is going to give us it is the remainder. Now when we divide a is 10. If we divide a divided by 2, definitely the remainder is going to be 0. Now what we are now doing, from everything we have been learning, that's programmed for it. That's why we are starting from the scratch, from the basic, so that everything can sync, we can be clear with everything. We've done this before, whereby we do double equals to, trying to do the comparison. You get in the comparison video tutorial in our previous video, we are doing the comparison. Okay, and now we are doing modulo from our arithmetic operations that we learn. We are doing modulo. Now we are combining all this knowledge together to be able to achieve whatever I want to achieve. Imagine you have been told to write a program to determine if the number that is being imputed is an even number or odd number, though we are assigning a year. Definitely we in our next video we can actually collect the data from the user. We can make use of the terminal, though in most cases we will not be doing that. In a real world application, it's going to be graphical, but definitely we're going to see how we can do that in our next video. All right, now we store 10 inside a and we are modulating with 2, and definitely the result is going to be 0. Are you getting it? The result is going to be 0, which is this condition now is true. And saying this, definitely it should be even. It's checking if a divided by 2, which 10, if 10 is divided by 2 is equal to 0, which is the modular division, is divided by 2 is equal to 0, definitely is going to be equal to 0. It's now even. Is divided by 2 is equal to 0. Definitely once it is 0, it is even. Then if not, it is odd. That is just what this means, and it's saying a, which is 10, is result, and which is this result, and we're storing it inside a string. Result is even. All right, let's check. All right, fantastic. You can see that 10 is even, and we can even change it to, let's change to 11. 11 is still smaller than 20 actually, and we can run it. Now we should get odd because there's going to be remainder 1. 11 is odd. That is it. I think that will be all for this video. We've been able to learn about 3 things here on this video. We've learned the ternary operators, we've learned the incremental and decremental operators, and we've learned the assignment operator. Thank you for watching. Don't forget to like, subscribe, and share with your friends and family. Bye.